Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
If they're like most people, you probably use the terms website and web application pretty interchangeably. I know I do.
Oh, absolutely.
You know, you talk about checking a site or using an app, and you don't really give it a second thought.
But our sources today, they're really clear on this. They are not synonyms. Not at all.
No, they're fundamentally different digital tools, really, built for completely different jobs.
And that distinction, it's so crucial now, especially for anyone in development. We're not talking about, small cosmetic differences.
Right.
We're talking about different kinds of software with different security needs, different scopes. Even how you maintain them is different.
Okay, so let's unpack that. Our mission for this deep dive is to cut right through that confusion.
Let's do it.
We're going to clarify what defines each one, why you might choose one over the other, and dig into some of the technical trade-offs that developers have to deal with.
Wow.
And to frame this right from the start, just think about the difference between, say, reading an article on Gru99 versus using Salesforce.
That's a perfect example.
One is for reading and viewing information, and the other is a complex piece of software you use to get work done.
Exactly. So let's start with the basics. The website. What is it?
Okay.
At its simplest, it's a collection of web pages. They're all interlinked, they're globally accessible, and they all live under one single domain name.
So like a brochure or a blog, something informative?
Precisely. It could be developed by an individual, a business. Its main purpose is to present information.
And when our sources talk about what makes a good website, it really boils down to the content, right?
It does. It needs high-quality, relevant content, navigation that makes sense.
And it has to be searchable. You need Google to be able to find it and index it easily.
That's critical. Its job is to showcase. It helps business with branding, with social proof, just by being there and looking good.
Okay, so that's the website. Now let's switch gears to the web application or web app. The definition here feels immediately different.
It is. It's defined as a software or a program that you can access with a web browser.
And that word software, that's the real tell, isn't it?
That's the first big flag. Yes. I mean, the front end, which you see, it's still built with HTML, CSS, and JavaScript, which all browsers support.
Sure.
But the back end, that's where the real complexity is. It's running on heavy-duty tech stacks like LAMP or Mean.
And the sources, they trace the rise of the web app directly back to the software as a service movement, SaaS.
They do, and it makes perfect sense.
Yeah, SaaS is all about using powerful software without having to download and install it.
You've got it. So web apps are, by their nature, cloud-hosted. They're highly scalable, so they can grow to handle tons of users.
And cross-platform by default.
Exactly. And because it's software, it has to be reliable. So it's heavily tested, usually with automated tests. It's designed to perform really complex tasks.
So if we had to boil it all down, strip away the jargon, what is the single biggest difference between the two?
It's the interaction. Without a doubt, the level of interaction.
Okay, explain that.
With a traditional website, the content is mostly static. You view it, you read it, but you don't really affect its functioning.
It serves everyone the same basic content.
Right. It's publicly accessible.
Yeah.
But a web application, that changes the game completely.
How so?
It's designed specifically for deep interaction with you, the end user. You don't just read the page.
You manipulate the data.
You manipulate restricted data. The application has to keep track of who you are, what you're doing, your choices, your identity.
So it's stateful. That's the term, right? The application remembers your state from one moment to the next.
Correct. It's stateful. It tracks the state of your interaction. And that immediately tells you why authentication is so important for web apps.
You have to log in.
You have to. You're working with your own private, personalized data. Think of your emails in Gmail or your customer records in Salesforce. That has to be protected.
Okay, but what about the gray area? I mean, say I have a simple marketing site, but I add a contact form or maybe a little login area for some premium articles. Does that make it an application?
That's a great question, because that's where it can get a little blurry.
Right.
For an informational site, a login might be an optional extra, like signing up for a newsletter.
Right.
But the main content is still open to everyone.
I see.
In a true web app, like a banking portal, the entire system is gated behind that login. The functions it performs are just. They're so much more complex than a website that just displays information.
So the website is the complete product you see in your browser, but the web app is the specialized software inside it that does the heavy lifting.
That's a perfect way to put it. The website kind of houses the application. The app development is part of the site, but the app itself isn't the whole website.
Okay, so if these things are so much more complex, handling security and all this logic, you'd think they would be a complete nightmare to maintain compared to just, updating a simple HTML page.
And you'd be surprised. Often, the opposite is true. And that's really why the whole SaaS model took off like it did.
Really?
Compared to old-school desktop applications, web apps are actually much easier to manage. Because they run in the browser, they use the same code everywhere.
Ah, so you eliminate all those awful compatibility issues.
Gone. You don't have to worry if your software works on 50 different combinations of operating systems and hardware.
As long as you have a modern browser on Windows, Linux, Mac, whatever, you're good to go.
You're good to go. And think about deployment. You can access them 24/7 from any device. You push an update.
And everyone gets it instantly. No more, please update your software pop-ups.
Exactly. And for mobile web apps, you get to skip the entire App Store approval process, which can be slow and costly.
And the cost model is different, too. It's usually a subscription, a pay-as-you-go model.
Which is often way more cost-effective than buying expensive licenses for desktop software. It's a huge operational win.
But, and this is a big but, it doesn't come without some major technical trade-offs.
Okay, here we go. This is where it gets really interesting. Let's start with the website drawbacks. They seem pretty straightforward. They are. A website can crash, which is obviously a disaster for a business.
Sure, and those simple contact forms can get you just buried in spam. And if you don't keep the info updated, it can become unreliable fast.
Right. But the trade-offs for web applications, they cut much, much deeper. They're about security and deployment.
Okay.
The sources are really clear on this. Security is never guaranteed. You're handling huge amounts of sensitive user data.
So they're a huge target for attackers.
A massive target.
Yeah.
They need constant specialized security work. And even though we said they're cross-platform, they might not support every browser with the same level of performance. Yeah. So developers spend countless hours just trying to make sure the experience is the same on Chrome, Safari, and Firefox.
That sounds frustrating.
It is. And this all leads to the biggest technical difference of all, and it's about how the software is actually built. We need to talk about compilation.
All right, lay it on us. Compilation, why is that such a big deal?
Okay, think of it like this. A simple website is like a Word document. If you see a typo, you just open the file, change the text, and save it. Done.
Simple enough.
But a web application is a functional program. It's more like a complex piece of software written in C++ or Java. The server can't just read the code line by line.
It has to be processed first.
It has to be precompiled before you can deploy it. The compiler turns all that human-readable code into executable logic that the server can run.
Okay, I think I follow.
Now, here's the kicker, the really costly part. If you need to fix a tiny typo in the web app's logic or change one small feature,
you have to do what?
All of those changes mean the entire project has to be recompiled and then redeployed to the server.
Wait. You're telling me for a simple one-line change, you have to rebuild the entire house?
You have to rebuild the entire house. For the simple website, you just upload the new HTML file. No compilation.
Wow.
For the web app, every tiny tweak means a full rebuild and deploy. That is a massive operational difference.
That complexity of deployment, then. That's maybe the clearest technical line between a website that displays content and an app that manipulates data.
It absolutely is. It impacts your risk, your time, your resources. It's why companies need complex systems, CI/CD pipelines, just to manage the process of pushing updates efficiently.
So after all that, what does this mean for you as you're browsing and working online? Let's try to put all the pieces back together.
Okay. A website. It's a group of interlinked pages. The focus is on displaying content, on branding. It's mostly stateless and open to the public.
And the web application, that's a software program you use in a browser. It's defined by needing a login.
Authentication, right?
And its whole purpose is to let you manipulate restricted data. It's stateful, and it runs complex logic.
The web app is better for complex work, no question. It's scalable, easier to maintain than desktop software, but
it pays a heavy price in security vulnerabilities and the huge effort it takes to recompile and redeploy the entire project for even the smallest changes.
And we established that web apps are easier to maintain long-term because the code is consistent across platforms.
Right.
Yet that very same structure means that every little change, every tiny update, forces the organization to recompile and redeploy the whole thing.
And that leaves us with a really fascinating tension, doesn't it? If the goal for modern companies is continuous delivery, shipping small updates all the time, how do they balance that need for speed with the inherent risk and slowdown of having to rebuild the entire application every single time? That collision between agile business goals and the strict all-or-nothing nature of application compilation, that's definitely something to mull over.
Hey, yo, haven't you checked out our new book yet? Link in description.